Hello guys, it is of course I, Trollface the Man, and welcome back to another video. In today's video, I'm going to be taking this light that I found in the trash, and I'm going to be restoring it. Not only am I going to be restoring it, I'm going to upgrade it, and in some aspects potentially side grade it. And what I mean by that is I'm going to be removing the ballast, doing a ballast bypass to allow me to run an LED in there instead, and not lose a bunch of efficiency, along with having some other issues that ballast can sometimes cause. So this light, unfortunately I broke it more than it actually already was, simply just didn't work when I had found it. So when you would hit this switch, the fluorescent tube in there would just slightly flicker and it wouldn't actually come on. And magically it fixed itself, which kind of sucks because I wanted it broken, so that way, gosh darn it, I would have an excuse to fix it. But there's other reasonings to fix this at this point anyways, as you'll see in a second. But it also has a very heavy-duty extension cord and comes with a plug-on here, which makes it a very useful work light. It's just not in the best shape. Okay, so yeah, I actually accidentally broke this before taking it apart. First off, I'm gonna unplug this. It's unplugged now. What ended up happening is I was trying to figure out how to get this tube separated, and it turned out that they had a little sneaky, you see this little thing right here? There's actually two parts to it before, but it's a little, basically, it says on, found it out from this, basically says a rivet that you pull out. It's like a little plastic flanged bit that goes ahead and sticks in there. And then you can go ahead and pull this tube off. So I was actually talking to the person that threw this out, and they said that they had this thing for I think like 20 years or something, and it just ended up breaking after they dropped it. And I think I might see the problem. It turned out it was more than likely just a bulb that they needed to replace, and I don't know why it spontaneously started working again because this bulb's in rough shape, but as you've seen, it was working. This bulb could just be replaced, and I was even thinking if I use some high temperature epoxy right here and then just kind of sure it up, it probably would be fine as it is. Interesting thing to note about this too is it has a metallic, it's not actually metallic, it's probably like mylar, I believe, reflective coating in here. And then there's actually a lens on the front that's meant to collimate light, and you can use it as a rudimentary sort of flashlight. And the way that that works actually is that just a little bit of the tip of this tube sticks through there, and then the light gets collected and shown through it. I'm gonna see what I'm gonna do with that later, but anyways, yeah, I could just replace this light and still use this thing, but again, I'm gonna bypass it, and the reason is because one, I prefer LEDs, they're more energy efficient. Two, the ballasts tend to fail. Three, one of these lights, because there are certain things that they've made, like regulations and stuff, where they force these lights to be used in certain areas. They're usually really expensive, like a lot of times $7 or more just to replace that one light, versus an LED that's much more efficient, better color quality and so forth, that I can buy for like $1. So yes, anyways, what I end up doing is I got these adapters that allow me to convert this socket type to a standard screw base. Two things, I actually cover this in a different video, but one of the problems is that because these don't have any ability to stop you from plugging it in either direction, that means that instead of the center part here being live and the outside always being neutral, they can be flipped depending on the direction that you plug it in, which can be dangerous because if the outer sides of these bulbs right here are not properly covered, which these adapters do a good job of covering that, those could potentially be a shock hazard if this outside ring is live. And also, I thought that there's a couple of different versions of this base, and it turns out this one's kind of universal. It can use all different versions, but if you have a light like this, you need to make sure you have the right version. And I actually tested in a different video, which I will link, and I'll also put a card up here, whether or not you could use different bulbs, incandescents, LEDs, and stuff with a ballast like this without bypassing it first. And there's some interesting results, some unexpected results with that. So if you want to see that video, again, I will link that in the description below and also put it up in the corner there. 2 screws right here on the side. I'm expecting this whole construction to be quite simple. So again, I made myself a lot more work when I went ahead and accidentally broke this part, but I did another video on a plastic welder before, which is amazingly useful, and again, I will link that too if you wanted to see it, but I believe I should be able to probably fix it pretty decently using the plastic welder. I'm just going to zoom you in for a second. So yes, we have let me zoom out just slightly. We have just live in, neutral in, ground. So live goes to this plug, which also chains off to the transformer here and to a switch. I got to be careful because this could have some type of capacitor or something, but I don't see one. It just chains off of here and goes into the transform, which then looks to come out and go into the switch. And then the neutral just goes straight into the bottom of the socket. And after the switch here, that also goes into the bottom of the socket here. So very, very simple. In order to bypass this ballast, we are simply going to, well, remove it. And that's going to require almost nothing. All I'm going to have to do is snip this live wire here and snip this live wire here, and we're going to reconnect those and solder them together, and I should be able to reassemble this. Now, something to keep in mind, this switch is probably rated for a low amount of wattage or current going through it because it's going to be limited by this light and the ballast and stuff. And if you bypass this ballast and then you put like a incandescent light, not that I would recommend that, but if you put like a really high wattage incandescent light, it would probably burn up the switch, which you don't want to do. But yeah, there's 2 more screws in here. There's all my broken bits I need to fix. Do not see an easy way to slide these out without using a tool that I don't have right now. So I think that those are just going to stay in for now. So this is one break right here. You can see it just kind of wants to slide back into place, which is pretty good. And this is the other break right here, which goes like this, and it also slides back into place. What I'm going to do is I'm going to super glue them, but I'm not going to rely on the super glue for structural integrity. I'm just going to kind of super glue it to hold it in place while I plastic weld it. Super glue's had enough time to set up. I have my plastic stapler. Very simple, slide in one of the staples in here. And when you press and hold the trigger, it heats up. Again, I did a whole video about this if you're interested in seeing it. We have that split here, so what I'm going to do is I'm going to heat up the plastic and I'm going to inset it right around where that split is. And release the trigger, give it a couple of seconds in order to cool, and then just back out the staple when it does. And I got a couple more spots over here I'm going to do the same thing for. There are a couple of different shapes of staples. This one actually is meant to go into corners, and I do have a corner right here I need to repair. So same concept, I heat it up. I just go ahead and melt it in place like so. And then these ones at least are tempered, so that way you can go ahead and just bend them like that and then the legs snap off. Otherwise you can use clippers. It's created a decently strong joint. Normally I would epoxy over something like this, but I don't feel like getting out the epoxy right now, so I'm just going to kind of run super glue into those channels and just give it hopefully a little bit extra gripping strength. But I think that should be all set, and then I just have this one to do on the other side, which is just the same process, plastic stapling and then gluing again. I'm going to paint these, but they're pretty grody, so I'm first going to try and clean them with mineral spirits. These I think should paint fine. This cap I'm not so sure about because it's very rubbery. Paint's probably not going to want to adhere to it, but I'm going to give it a shot anyways. Too bad I'm not a fancy big YouTuber with a nice ultrasonic bath that I can just run these through. That would be nice. No, I gotta cheese it, clean, and then paint like a scrub. Got some primer that's supposed to bond to plastic. Again, I think this is going to be the problem child, if there is one, because it's actually a rubber and not a plastic. Interesting. That must be the mineral spirits. I'll have to give that more time to dry. Well, this is going to need several coats and time to dry, so while that is, I figured I would be productive and see about fixing this tube. Now you might ask, how do I fix this tube when it's so jacked up? And it's true that I probably could recut an entire new tube, put it in there, or polish this and finish this up, but why would I do that? Instead, what I was figuring is I'll just scratch it up more. What I mean by that is, if I simply use some sandpaper on here, I can diffuse this entire surface, which will make a much softer light, and it hopefully shouldn't look too bad. So I'm going to spend a little bit of time. I have 800 grit sandpaper just scuffing up this whole surface, trying to make a diffused cover for this. The 800 ended up being too fine for the amount of diffusion that I wanted. So instead I'm using 220, and it seems to be doing not too bad. I got this flashlight here and the diffusion doesn't look too bad at all. It says a cheap flashlight I bought off Amazon that's been pretty decent so far. I'll link it if anyone's interested. But I did notice something, which is that there's some cracks in the top here, probably from being dropped. However, the good news is that super glue, even though if it doesn't want to stick to most plastics, actually works amazingly when it comes to acrylic. So I'll just put a little super glue in there and glue it back together, and it should be probably as close to as strong as if it was not cracked in the first place. Interesting note, the area where I glued on the outside, some of the super glue got rubbed to actually turn transparent again. I'm just gonna really lightly sand that again, but I thought that's kind of interesting. It's almost like a finish you could put on there to give it a gloss. It's been a couple of days. I actually got horribly sick and was vomiting along with other unpleasant things. However, I am doing at least decently better now, so I figured I would continue this. The paint job on this actually turned out very, very nice. I've never actually had paint on plastic turn out so well before, so I'm very happy with that. However, this was the rubber part, and to my suspicion, it hasn't really set up properly. It's kind of tacky. And I tried heating it up in my oven, and I ended up melting it slightly. So I shoved it back on here as quick as possible to hopefully help it maintain some of that shape, but it just didn't work out well. So now let's actually get to bypassing this ballast. I do believe I called this a transformer before. I absolutely did not mean that. It is not a transformer. This is actually an inductor. It's not transforming the power from a lower voltage to a higher or vice versa. It is actually just providing, well, inductance. It looks very much like a standard transformer, but it's not. I just ended up misspeaking in terms of that. All right, so as I mentioned before, we're going to go ahead and bypass this. I have my soldering iron. I'm actually running it off my little Ryobi inverter, as I had mentioned in a different video. It's very, very useful for at least very brief soldering jobs like this, instead of me trying to grab an extension cord and stuff. So for this, first off, I'm going to make sure it's unplugged. It's unplugged, and we are literally just going to bypass this. So that's going to involve cutting this and cutting this. Now, I did measure this. This whole thing is basically just designed to limit the amount of current that this fluorescent bulb receives. If it receives too much current, then it will just burn up. So this just limits that to make sure that doesn't happen after it initially starts conducting. And that's one of the reasonings why that it likely works with bulbs that don't require that much current, like the LEDs and stuff, but causes problems if you try and use the incandescents. This says it's 13 watts on here, which matches this bulb, so it should theoretically only allow about 13 watts of current draw. I did test this bulb. I tested the output of this when I didn't have a bulb in here, and it was 120 volts, which matches the, the standard line out here. And then with this bulb in place, it was jumping between 54 and like 70-ish volts. So right here, we're going to strip this down. That is a tough casing. Might be because it's so old. It's also solid core wire, which is kind of interesting. That is very tough casing. Every once in a while you come across a wire that's just like that. Now, this is interesting because, again, it is solid core wire. I'm used to stranded, and usually what I would do is I would twist that together, which I'm going to inevitably do here, I think, but it's just not quite what I'm used to. What I'm also going to do is I'm going to take some shrink tubing, and I prefer to cut 2 pieces normally. And slide one on, and then slide the other on over top of that, just to kind of provide a double sort of insulating barrier. So for this, I'm going to take this wire and just kind of fasten it around. If this wasn't just for this small thing, I wouldn't recommend. I'd recommend doing some other different, more sturdier connection, robust connection for the solid core wire, but I actually, again, wasn't actually expecting to see the solid core in here. I can pull as hard as I want, that's not coming loose, which is good. Now I'm going to put some flux onto it. Not that much flux. Ooh, wait, definitely not that much flux. Nope, come on. There we go. And we're just gonna flow a good amount of solder on here. Being careful not to shrink the heat shrink tubing nearby. Sometimes the heat can conduct through the wire. That looks good. I'm going to grab a pair of snips and I'm going to trim off these little peaks. I don't think I can quite get it with this. No, I can't. Snip. Snip. Now, it's going to be heat shrink tubing. That enough for me to get this other piece on top of it. Just overlap them slightly. And now we should be reasonably electrically isolated. And in reality, that should be it. That should all be bypassed. This is actually strange how simple this seems to be. Like normally I would expect to see a lot more for a ballast, but we now can go ahead and reassemble this. And it should be significantly lighter without a ballast in it. So this comes up like this. Well, I seem to have persuaded it back together the best I can. So now, I just had to refasten those screws there. Alright, now the test will be to see if this actually still works. So I can see the live right here. So I'm going to match the live up with the live in my adapter, which should be this pin here. It'll work again either way, but just it's best to match those if you can for safety reasons. And all we need now is to put a light in there. Oh, first I need to plug it in. Then, voila, look at that. Now, I know what you might be saying. Troll, there's no way that that tube is going to fit over the top. And you are absolutely right. And so I had thought of a couple of different things for that. One of which being, I could get one of those longer LED tube lights, but the problem with them is that they tend to be very expensive. They'll want to charge like $4 a bulb. Then I realized something. I've been holding on to some broken LEDs like this for absolutely ages, not knowing what to do with them. And I was figuring, if I chip off the rest of the glass, these might just be the perfect size to go ahead and fit inside of this tubing along with the adapter. Yeah. So I think that is going to be what my light source is. So I'm going to just very carefully chip off the rest of this glass here and get that ready. Now this bulb would be in no way, shape, or form safe to use normally anymore because these two contacts here would be live. So that would be an electrocution hazard. However, because this is going to be contained inside of a tube, I think we're going to be okay. And we plug it in again. Yeah, that works fine. Then the tube should fit right over top of it. Oh, I like this. I like this very, very much. I'm going to put this reflector back in there. Even though if this is diffused, because it will help direct the light a little bit more. But there was also the matter of the lens that goes on the top and then this little piece of plastic. And I don't know if I put this up here, if this plastic will let enough light through to make this lens even at all usable. But I guess that's one of those things we can just go ahead and find out right now, eh? Okay, so I slide this back in, and this thing pretty much holds that in place. Then we put the lens back on top. The lens could fairly be polished if I wanted to get into that. And then put this rubber cap back on. And now, I should be able to put that back in place. And aha. Oh, I just blinded myself. That is great. That actually works better than I would have expected. It looks awesome. It's lighting up a ton. And I could put, preferably I prefer daylight versus like a warm white like this. I could put a daylight one that I have LED that's broken in here too instead. But this actually looks pretty dang good. And again, I mean, it was something that was plucked out of the trash that was just going to be thrown out anyways. And now I have a new work light that also has that extension cord on it, which is a godsend for when you're working sometimes. And it seems like that the extension cord is probably, I'm guessing at least 15 amps, maybe 13 amps to stay on the safe side, but it says it's 16 gauge, so yeah, you should be able to run pretty much whatever off of there that you might need. But yeah, that worked out great, and that the sandpaper sort of diffusion on here works really good in terms of you know, just spreading out that light along with the reflector, and it pretty much lines up right in the center of everything. You can see we get a very mild sort of flashlight effect. Very mild, but you know, I'm not too concerned about that. If I were to put anything else up there, I'd probably end up losing a significant more amount of the light, which I'm going to use this a lot less than I actually use the regular work light thing for it. So, well, anyways, guys, I hope you enjoyed this video, and if you do, please remember to leave a like and to subscribe if you haven't already. And thank you to my patrons for your awesome support and funding that allows me to do certain videos that I might not normally be able to do. I appreciate that very much. I also appreciate just you guys in general for watching, and yeah, I'm pretty happy with this. And because this LED is only like a 7-watt LED, it actually should run much cooler in there compared to this one before. So I think it ended up working out pretty well. Thank you guys very much for watching, and bye. There was a little bit of flickering, and I just now realized that apparently one of the filaments on here is damaged, so it's actually kicking on and off. So I'm going to replace that with a different one that I have around here. I didn't realize that was damaged. So this instead is a daylight bulb that actually should have a higher lumen output, but because it only has 4 filaments, I don't have too much confidence in its longevity. However, it is one that has also already been broken, so otherwise it's just a waste anyways. So screw that one in there instead. And I think daylight and stuff is usually better to work by, in my opinion anyways, in terms of color temperature. But yeah, actually this one looks much brighter. I'm going to put this in here. Eventually I might decide to replace this this little piece of plastic here with like a self-tapping screw, but oh yeah, that's okay. That other LED was super dim compared to this. This is way brighter. Much better. It's actually probably good that other one was bad, because yeah, no, this is a way better experience. Alright, well anyways, thank you guys, and bye. Oh, we're actually getting more usable light. I suppose I should check this too to make sure it's still working, which it is. Very cool.